Hello, y'all. So today we are going to do another math video, and we're going to talk about how we gain familiarity with factors and multiples. More specifically, we're going to talk about some prime and composite numbers. So let's get to it. So the key terms that we're going to talk about today are prime numbers, composite numbers, factors, and multiples. So what are we talking about here? Well, our first definition, a prime number. So a prime number is a whole number that can be divisible by 1 and itself. All right, so key part here, it has exactly two factors, okay? Exactly two factors. Alrighty, so continuing on here, a composite number. A composite number is a number that has more than two factors. So it has factors other than 1 and itself. All right, so let's dig a little deeper with a diagram here. So these are numbers 1 to 100, okay? And the numbers in blue here, let's just try it out with 3. Is 3 a composite number or a prime number? So we have 3 here in blue. 3 is a multiple of 3 times 1. Now it doesn't have any other factors, just 3 and 1. So indeed, 1 and itself. So 3 is a prime number. Alrighty. Let's try one of these numbers in whites. If all the blue numbers are prime, just as we see 3 is prime, then for sure the numbers in white are going to be composite numbers. So for instance, let's take 18. 18. So we have 18. Yes, we have it being multiplied 18 times 1. All right, factors 18 and 1. Itself in 1. Okay, but we can break down 18 and make another one. So how about 2 times 9? That is, these are also two factors of 18. Okay, I know 9, it's also a composite number. So let's see here. 9 can be broken down to 3. So let's see. 3 times 6. All right, 3 times 6. So that's another set of factors we have here. So 18, its factors are 1, 2, 3, 6, 9, and 18. These are the factors of 18. So indeed, it is a composite number, not a prime number. All right, let's continue on here. Okay, going to our next term, factors. So we just saw a list of factors, and a factor is a number or quantity that when multiplied with others produce the given number or expression. All right, so let's see here. If we were to go back to 18, we have 18. So for the factors here, we have 1, 2, 3, 6, 9, and 18. These are factors of 18. Okay. And let's see here. These factors work together to create multiples. So by definition here, a multiple is a number that can be divided by any other number without having a remainder. So if I was to take 18 and divide it by, not 16. Let me back it up here. If I was to take 18 and divide 18 by 6, 18 by 6, then we would have 3. And let me write that out this way, not long division. 18 divided by 6 equals 3. Okay, so 18 here is the multiple. It can be divided 6 ways, and we would have 3 with no remainder. All right, so let's try to identify if these are prime or composite numbers. So you could use that chart that I had displayed before, but let's just try it out. You know, it's 5. Number 5. Is 5 prime or composite? So let's just think about some of those fact families where 5 is a multiple. So 5 equals, for sure, 5 times 1. Yes. But we can't break it down any other way without remainders existing. So indeed, this is the only fact family we have. And that tells us that 5 is prime. Yeah. All right, let's see what other examples we have here. 11. Okay, 11. Let's take 11. Oh no, let's go back. All right, so we have 11 equals, for sure, 1 times 11, or 11 times 1. But it cannot be broken down, divided by any other number into even parts without a remainder. So for sure, here 11 is prime. Yes, it is only divisible by 1 and itself. It has exactly 2 factors. All right, 24. Let's try this one out. So 24, if I was to write 24 as a multiple, it could be broken up into how many factors? Well, it's an even number. So what can we multiply by 2 to get 24? It'd be 12. Okay. All right. And let's go ahead and write down 24 times 1, because that is indeed another set of factors that we can put here. All right. So already we see that it is not a prime number because it has more than 2 factors. But let's see. 12, we could divide 12 evenly into 6. So 6 must also be a factor of 24. So 24 is also a multiple of 6 times 4. Okay. All right, so the factors of 24, we have, I'm going to do it in numeral order. 1, 2. You know what? I think I missed one. I sure did. 24 is also a multiple of 3 times 8. So our factors are 1, 2, 3, 4, 6, 8, 12, and 24 itself. Wow, that's a lot of factors here. We have 1, 2, 3, 4, 5, 6, 7, 8 factors of 24. Yes, indeed, that is a composite number. Alrighty, let's get to the next one. 66. So let's think of some factors of 66. Of course, we can start off with 66 equals 66 times 1. Okay. Now let's see here. I know for certain 66 is 2 times 33. Alrighty. And another one here that we have is 66 times 22 times, what do y'all think it is? It's 3. Yes, 3. Okay, and then let's see here. 66 is also a multiple of 11. So what can we multiply times 11 to get 66? That will be 6. All right. So this also has 1, 2, 3, 4, 5, 6, 7, 8 factors. So indeed, 66 is a composite number. All righty. Okay, so if you were following me on Facebook earlier this week, I posted this trivia question. What is the smallest prime number? Now I got some ones and I got some twos, so let's break this down by definition. So a prime number has exactly two factors. Exactly two factors. Okay? So for one, let's talk about one here. 1 can be represented by 1 times 1. Okay, so how many factors do you see here? There's only one factor. That's 1. So it doesn't have exactly two factors. It has only one factors. So actually, 1 is unique here. It's neither prime nor composite. All right? So let's see. Let's go down to the next one, 2. Our fact families of 2. We have 1 times 2. Okay. And how many factors do we have for 2? 1, 2. Yes, 2 and 1. 1 in itself. So here we see that 2 is a prime number. And we can work it out further and see that 3 is also a prime number. But that's not what the question is asking us. The question is asking us, what is the smallest prime number? So the smallest prime number here would be C, 2. All right. Check y'all guys later. Thanks for tuning in.